we have to find the variance of the distribution. Now, in order to find the variance of the distribution, first we have to find the value of k, and also we know that maximum probability is 1. So the probable values are given in the table. So sum of these values must be 1 plus k by 2 plus k by 6 must be equals to 1. If I simplify, then the value of k will be 1. Now we know the formula of variance v of x is nothing but e of x square minus e of x, which is mean, whole square. Now in order to find the variance, first we have to find e of x square as well as e of x whole square. To find that, let us make a table of x, then p of x, x into p of x, and x square into p of x. The values of x are minus 3, minus 2, 0, 2, and 3. Let us go for the sum here. Now the p of x values is nothing but 1 by 12. Just multiplying this k by 6 to this minus 3. Next value will be 3 by 12, then 4 by 12, then it is 1 by 12. And sum is nothing but 3, 7, 8, 9. So 1 by 12, 3 by 12, 4 by 12, 3 by 12. There is one more thing which is 3 by 12, which is missing out. Minus 3, minus 2, 0, then 2, 3. And if I add them, it will be, this is 1 by 12, this is 3 by 12. Sum will be 1. And similarly, x into p of x, minus 3 by 12, minus 6 by 12, 0, 6 by 12, 3 by 12. If I add this, sum is nothing but 0. Similarly, x square into p of x, 9 by 12, 12 by 12, 0, 12 by 12, 9 by 12, and 42 by 12 will be nothing but their sum. Now, v of x is nothing but 3.5 minus 0, because the mean is nothing but 0, which is nothing but 3.5. So the option is C.
Linear voltage regulator circuit is shown below. Calculate the minimum value of the load resistance required to maintain the output voltage constant. Okay, according to the data, the Zener diode must be operated in the breakdown region in order to get the constant output. Means V0 should be 20 volts always. So V0 is 20, which is nothing but 30 divided by 20 plus RL into RL. So 3RL is 40 plus 2RL. So RL is 40 ohms, which is option B is correct. Find the number of 2-input NAND gates required to implement the following Boolean function. Here, if we simplify this expression, A bar B 1 plus CD plus BC bar 1 plus D bar and this is one more plus D, okay, plus BC. This is A bar B, BC bar plus BC. Here A bar B plus B, C plus C bar, this is 1. So B 1 plus A bar, that is B. So after simplifying Boolean expression F, we will get B. That is B letter is already available. There is no implement to implement using 2-input NAND gates. Okay. Hence option A is correct. After executing the following 8085 program, what are the status of the flags? Okay. Means we have to check the last instruction, that is ORAC. See how doesn't affect the flags at all. So ORAC, that is O-ring accumulator with a C, is the arithmetic instruction or logical instruction which affects the flags. So accumulator contains the contents of B, that is 91H, and C contains A8H. So O-ring of these two numbers, that is 101001. Okay, this is 1010 1000 A8H. So O-ring of 10 is 1 0 0 1 1 1 0 1. So carry flag is 0, 0 flag is 0, sign flag is, that is MSB bit is 1. So option D is correct. Output of a multiplexer shown below is, see, A can take two values, that is 0 1. We have to look at expression Y. So if A is 0, the Y is I0 is selected, I0 line is selected, I0 is further connected to A, means output is 0. If A is 1, I1 is passed to the Y, that is 1 is connected to I1, hence Y is 1. So Y is nothing but A, hence option C is correct. C. Consider an op-amp circuit shown below. Find V0 when switch is closed. When switch is closed, that means there is no, here 4 ohms is short circuited with the switch. Here this point is V0, and from the virtual short circuit concept, this node is also having a potential V0. Because of the switch closeness, this V0 appears here, that is this one. Similarly this one, all these node potentials are V0. So there is no current towards this side, that is current is 0 into the op amp. This is V0, this is also V0. So V0 minus 6, if we apply the KCL at this node, V0 minus 6 2 by V0 minus V0 by 4 equals to 0. V0 is equals to 6 ohms. Okay, from this one option B is correct. Similarly, find V0 when switch open. Okay, when switch is open, options are A 12 volts, B 6 volts, C 3 volts, D 4 volts. Okay, switch is open, this node potential is V0, now also V0, but because of this resistor, this node potential is not equals to V0. But what happens is this 4 ohm resistor, this 4 ohm resistor, means this node potential here V0 equals to, if I am indicating this one is V0 1, V0 is V0 1 by 8 into 4, that is V0 1 by 2. So V0 1 is nothing but 2 V0. Okay, so now if we apply the, if this is V0 1, this is also V0 1. If this is V0 1, this is also V0 1. If this is V0 1, this is also V0 1. So if we apply the KCL at this node point, that is 2V0 minus 6 by 2 plus 2V0 minus 2V0 by 4 is 0. So V0 is nothing but 3 volts. Hence option C is correct.